Hi guys. So what we're going to do today is we're going to look at a new type of function called a piecewise function. So what a piecewise function is, it's kind of what it sounds like. It's little pieces of different graphs that create one function. So what we're going to have here, instead of just one equation and that's the entire thing we're graphing, we'll graph one function for one domain. We'll graph another function for another domain, and so on and so on. So to start, just to get familiar with what these are, we're just going to evaluate some points on these. So what a piecewise function looks like, this first one has 3 parts. Now they don't have to have 3 parts. They could have 2 parts, they could have 7 parts. It just depends. But what you notice about each part is you have an equation and you have a domain. So each of these, I have f of x equals 4 for the domain, negative 2 to 3. I have the equation, negative 3x minus 7 for the domain, x is greater than or equal to 3. So in order to evaluate these, we'll start with the first one, f of negative 4. That means when x equals negative 4, what does y equal? Well, to figure that out, what I'm going to do is I'm going to take negative 4 and I'm going to plug that in for x. The problem is which of these 3 equations do I do? I'm not going to use all of them. I'm only going to use the one that actually has a domain that includes the x value of negative 4. Negative 4 is less than negative 2. Negative 4 doesn't fit this domain, so I don't worry about this equation. Negative 4 doesn't fit that domain, so I don't worry about that equation. The only one I worry about is the top one. So I just plug it into the top equation and get my answer. All right, now looking at the next one, negative 2, okay? Again, 2 of these have negative 2. Only one of them, though, is or equal to negative 2, and that would be the middle one. So on that middle one, the y value that I get, there's really no work to do there. It's just 4. All right, f of 0, so I need to figure out which domain includes 0. Well, 0 is in between negative 2 and 3. So I'm using the middle equation, which is 4. Looking at the last one, f of 3. So when x is 3, this one includes the or equal to. This one is not or equal to. It's really, really close to it, but doesn't actually equal it. So I'm going to plug 3 into that equation. So negative 9 minus 7 is a negative 16. And then the last one, when x is 5, well, when x is 5, x is greater than or equal to 3. That's the right domain. So I would plug 5 into that equation, which gives me a negative 22. All right, now looking at this next one, we're going to use the graph to evaluate. This is actually something you guys have already done before, okay? But now you just know that this graph is an example of what a piecewise function looks like. So to evaluate f of negative 1, what I would do is just see when x equals negative 1 on my graph, what's the y value? And it's 0. All right, when x is 2, what's the y value? It's 1. When x is 1, what's the y value? Well, there's 2 potential places there. The open circle does not count. Remember, the open circle means I get as close to it as I can, but I don't actually touch it. So the only one I'm using is the filled in circle, which is 1. F of negative 2, that's the filled in circle. And f of 0, when x is 0, y is 1. All right, so now we're going to go ahead and actually draw these graphs. So in order to draw these graphs, again, we need to consider the domain and the function. And there's a couple different ways you can do this. If you're pretty comfortable graphing, what I would do is I would just graph the line 2x minus 1 to start. So 2x minus 1 has a y-intercept of negative 1 and a slope of 2. So I'm going to graph that line. But before I actually draw the line, I'm only going to graph the part that fits this domain. So when x is less than or equal to negative 1. So negative 1 is the first x value on this graph. So I'm only graphing this part right here. The other way you could do this is you can consider the endpoint. You can take this point and plug it in. So 2 times negative 1 minus 1. That's negative 2 minus 1, which is negative 3. So negative 1, negative 3 is a filled in circle. Because again, it's filled in because it's or equal to. So negative 1, negative 3 is the endpoint of that graph. Everything to the left, because it's less than, has a slope of 2. All right, now let's go to the right one. Again, if you want to just graph the line negative x plus 3, you definitely can. But again, what we're only going to include, though, is when x is greater than 1. So I'm going to erase all of that. I also can't have a filled in circle at that point. I need to have an open circle at that point. because it's not or equal to there. Again, if you want to find that point exactly, you can take 1, you can plug it in. So I know that 1, 2 is where my open circle is. Everything to the right, because it's greater than, has a slope of -1. All right, let's try the next one. Same idea, but this time there's 3 equations. So I'm going to graph the line 1/2 x when x is less than -2. I'm going to go ahead and plug in -2 just to see what that endpoint is. So 1/2 times -2 is -1. So -2, -1 is going to be an open circle on this graph. Everything to the left, because x is less than, has a slope of 1/2. Now let's go to the middle. I have the line f of x equals -1, horizontal line. So when x is -2, y is -1. That is going to be a filled-in circle because it's or equal to. Well, problem is here, we already have an open circle. And that's actually not a problem. Anytime you have an open and a closed circle, you just make it a closed circle. They overlap each other. That function is actually what we say is just continuous now at that point. Then we're going to continue this horizontal line until I get to 3. At 3, it's an open circle because it's not or equal to at that point. All right, then the last part of this graph, when x is 3, I end up with a y value of -3. So 3, -3 is going to be a filled-in circle. Everything to the right, because I'm graphing when x is greater, it's going to have a slope of -2. Again, if you wanted to, you could graph the line -2x plus 3. But again, we would just end up erasing those points because we only want to graph when x is greater than or equal to -2. All right, so the next one's a little bit unique. What we have here is we have a certain function everywhere except for 1 point. So when x is not equal to -1, every single other place, 7, 12, -3, -0.9999999, -1.00001, all of those places, it's the line x minus 2. The one place that's not true is when x does equal -1, the y-coordinate is 3. So what that tells me is -1, 3 is just going to be a point on this graph, a filled-in circle. Every other spot in this graph is going to be the line x minus 2. In order to show, though, when x is not, or when x does equal -1, that it's not this line, what we're going to do is we're going to figure out what would that point be, and we're going to put an open circle there. So if I plugged in -1, well, -1 minus 2 is a -3. So what that means is that -1, -3 is an open circle. Because if this graph didn't have this little not equal to, that's the point this line would go through. And then everything else, I'm just going to graph the line x minus 2. And my graph is going to look like this. It's got a little hole in it. And this is going to come back second semester, these lines with the holes like this. But again, the reason we plot that open circle is because we still get really, really, really close to that point. You still get to -0.9999999 and -1.0000001. But at the actual x value of -1, your graph does not have a y value there. All right, this last one, if you feel comfortable, pause the video, try this one on your own. All right, so looking at this last one, I'll go ahead and plug in my endpoint. So that's going to be a -1 plus 2, which is going to be -3, 1. That's going to be a filled-in circle. When x is less than, so everything to the left has a slope of 1/3. All right, let's look at the middle. Between -3 and 0, both will be open circles because neither one is or equal to. So if I plug in -3, so -3 is +3. 3 minus 2 is 1. Plugging in 0, 0 minus 2 is -2. So -3, 1 is an open circle. Now there's already a closed circle there. That's fine. Leave it a closed circle. 0, -2 is going to be an open circle. Everything in between. And I just realized that I had graphed -3, -1. We fixed that for you guys. There we go. Sorry about that. There's -3, +1. Okay. All right, then everything in between those 2 points is going to have a slope of -1. All right, then my last piece here, x squared minus 2. So that's a parabola, it's a quadratic. If you don't remember this from Algebra 1, this is going to have a vertex of 0, negative 2. Now, 0, negative 2, it's going to be an open circle because it's not or equal to. There's already an open circle there. We'll just go off of the same open circle. Now, if you don't remember what that quadratic looks like, we will review these later on this year. They are going to come back, so don't get too excited. We're going to do a lot of stuff with quadratics this year. But if you don't remember, plug in some other points. Plug in 1. Okay, if I plug in 1, 1 squared minus 2 is negative 1. If I plug in 2, 2 squared minus 2 is 2. If I plug in 3, 3 squared minus 2 is 7. We're just going to go off my graph a bit. But there's my parabola. All right, so what we're going to do now is we're going to go backwards. We're going to write the equation for the given graph. So this really is going to be good review for domain and range. Also some review from Algebra 1 of writing the equations of some of these functions. So what we're going to do is just start by writing the equation of the first part. So I'm just going to write the equation of that line. Well, to write the equation of that line, I need a slope and a y-intercept. That has a slope of negative 1/2. It's got a y-intercept of 1. Then I write the domain. Well, the domain happens when x is less than 2. Not or equal to because there's an open circle there. Then we go to the next one. So the next piece right here, that has a slope of 1, and I can't see the y-intercept. So I can either solve for it algebraically, or in this case, what's going to be easiest, just continue that graph, and you can see that that y-intercept would be negative 1. Then we write the domain. It's or equal to, because there's a filled-in circle, and it's when x is greater than or equal to 2. All right, let's go ahead and try this next one. So this next one has 2 pieces. We've got this line with a negative slope, and we've got this line with a positive slope. So let's go ahead and write the equation of the blue line first, and then we'll worry about domain. Well, let's go ahead and find the slope of that line. So let's count our rise over run. So it's got a rise of 1, 2, 3, 4, and a run of 3. So that has a slope of negative 4/3. Now the problem here, though, that y-intercept is not going to be easy to find. Even if I continue this graph, it's not going to be a whole number. So we need to solve for this equation algebraically. So what you did in Algebra 1 to find the equation of a line when you knew the slope and a point was you used point-slope form. Y minus y1 equals mx minus x1. So y minus y1, I'm going to go ahead and use the vertex as my point. So I would do y minus 1 equals negative 4/3 x plus 5. So y minus 1 equals negative 4/3 x minus 20/3. Negative 4/3 x minus 20/3 plus 1 would be plus 3/3. That would be a negative 17/3. All right, now we're going to go ahead and write the domain for that blue part. So that blue part happens everywhere that x is less than negative 5. Now the or equal to here, if you put it on this part or you put it on the other one, it does not matter. You can put the or equal to on either place. If you put it on both, that's fine too. I usually just put it on one, but just make sure you have it on there somewhere. All right, now let's write the equation of the purple graph. So the purple graph has a slope. Again, let's count the rise over run. Okay, slope is 4/3. And then let's write the equation of the line that goes through that point. Y minus y1 equals mx minus x1. So y minus 1 equals 4/3 x plus 5. So y minus 1 equals 4/3 x plus 20/3. Add 1, which means we're adding 3/3, which is 23/3. Then we write the domain. This is happening when x is greater than negative 5. And again, I already have the or equal to, so I'll just leave it there. But if you flipped it, if you made this one just less than this one or equal to, that's totally fine. It does not matter which one. All right, so last one. If you feel comfortable, pause the video, try this one on your own. Okay, we'll start with the first piece, which is this horizontal line. Horizontal line is just the line y equals 3. That's it, no x's. Domain, it's an open circle, so x is less than -1. Then we go to the middle. The middle is a parabola. It's been shifted up 1. So that equation is x squared plus 1. Domain for that is between -1 and 2. It should be an or equal to at -1, not an or equal to at the 2. Then the last line, that's got a slope of -1. Let me use the marker, not the highlighter. Can't see the y-intercept, but this is an easy one. If I continue the graph, I can see it's just -x plus 4. Domain here, it's a filled-in circle, so it's going to be or equal to. So when x is greater than or equal to 2. And that's my piecewise function. All right, so that's actually it for this unit. Again, this last day really kind of combines some algebra stuff you guys have done. Really trying to review you guys on that domain idea as well.